response it. So that's all this is doing.
And
so what we're trying to do is structure all of these calls from Star Commander into an OS client rather than doing inline code there.
We can actually have, I mean, since our primary driver is OpenStack at this point, I mean, at some point we can consider having a separate service which serves only the OpenStack commands and does the multiplexing, forwarding, etc. We don't have to necessarily go through our management.
What this is doing is tunneling, right? We basically do the tunneling after that. So now, let me give you the wrinkles of what else we have to do in addition to tunneling. Sometimes we do open up the command and response, okay? So there is a lib commander. So this is used to do something. For example, in SkyMap sends a request for an authentication, right? That comes back. The token ID is embedded somewhere inside the thing in the OpenStack response. So we actually open up, we don't just give it back to the UI saying, hey, here's your token, take it. So what we do is we open up that request, take the token ID out, and store it on RDS cache. So that's the difference. So now, effectively, which means it's not a transparent tunnel where UI sends something, we shove it to the other side, get the response, and give it back to the UI. And there's one more thing that we do. For every response that comes back, we actually do a transform URL. Okay? So why do we need to do it? So think of it as, let's say when you click on a project, it shows you a bunch of VMs, right? Now each of those VMs is actually a link to click on and get more information, isn't it? And all those URLs have something which says console.zerostack.com / server / something get whatever, right? Now when you look at it, the URL says console.zerostack.com, right? But when actually OpenStack sends a response, it will say 10.1. whatever this thing / Nova / v1 / servers. This is the URL to reach this VM. When you say create a VM, it responds with, oh, I created a VM, here's the URL to reach this VM. And that URL will have the local IP addresses and everything, service address. It won't have a console. Now if you just give it back directly all the way to the UI doesn't know, like you don't want to do transformation of, oh, 10.01, what the heck does it mean? It's console.zerostack.com or what is it, right? It can't do the transformation. So what we do is, in Star Commander and in sometimes in SkyMap, we actually open up the request, we do some processing of it, then we put it back and send it back. So here in Star Commander, it mostly just does URL transformation. It opens, URL transform, marshal it back and then send it out. SkyMap opens it for a session ID, but over time we'll have more of these where you open and look at everything. Okay? Now I think that covers most of the Sky part of it. So one thing that we added recently is just like, by the way, all of these guys have public and private ports. So Skygate also has a public port and it has a private port. So for example, status lookup, you do on the private port. Status lookup, that route is not available on the public port. The public port is more for Stargate to talk to it. And even the command sending is on the private port. So it's not on the public port. Okay. So we added a new module called SkyGlass very recently, because SkyMap used to have the same public and private port where the UI was talking to it, and we had a private port to do this thing. We separated out all of that into the SkyGlass component. Okay, and what the SkyGlass is really a more debug utility where we added URL routes to do status and other lookups of aggregated information. And think of this SkyGlass as really, this is the customer UI. Okay? SkyGlass, think of it as the NOC UI. Okay? The idea is that over time we'll build our own UI which lets us examine the state of the state of our own cluster and state of the different customers, environments, what's going on.
NOC?
Network Operations Center. People sitting there with lots of monitors. Like the headquarters of the train station and everything sort of a thing, right? So basically we'll build our own UI which doesn't have to go through the customer UI, so we can examine state and debug issues and whatever else, right?
So monitoring should all probably go here.
Yeah.
Especially.
So all the rest of, lot of the private information which the customer doesn't need to see, all of this will go through this one. And the idea also is that we don't want to bring down and bring up SkyMap based, just to do our own debug improvements.
Right.
So you have an independent process which can sort of independently be deployed. As of now, it's just one module that runs in one server. We're not even running it in a distributed manner. Because this can get killed anyway, like the user functionality doesn't get affected. So through this, we actually have an interface called DCLI. This is the one we actually use in the cloud as an interactive CLI. It's called D for debug CLI. We have different CLIs all through the system. We have, in the Sky, we only have this, and Skynet, Sky CLI. Okay, I'll come back to what is Sky CLI. The DCLI part of it is really, you can just start it up if you go to a cloud machine. And the getting into a cloud machine also is we don't do direct access. Your keys need to be added, then you can SSH in, and then you can go to one of the VMs. We don't have direct password-based login. So what the DCL lets you do is examine different statuses with respect to what are the list of connections to a Skygate or all Skygates, what is the list of accounts in the database. So it does two different things. To Skyglass, it goes to the Cassandra database. So it gets like database status, and it can also do runtime status. So over time, the idea is that we keep improving this thing to collect more information that can show how many customers are there. So for example, we use, Puneet has a script which just runs DCLI to collect the health of how all the customers are doing. So what it does is, okay, DCLI, get me account ID for this customer. From that account ID, okay, call the database to look up what are all the list of hosts and the list of cluster IDs. And from that, okay, use that cluster ID to look up the health of what's going on and how many VMs are created. So we're trying to keep improving the DCLI as a way to sort of explore information, and even if you want to do some management of delete some stale stuff, bad information that got polluted, all of that stuff we start adding to DCLI. Okay. So the star side, I think we already talked enough about it, of all the different modules and processes and how the ensemble works. So just like there is a star CLI and an equivalent one in the Sky, this is really used to more internal manage the processes. We debug our distributed system of how it's starting, stopping services. So we can use this to we use this on the customer side a lot, and we're trying to debug why our distributed system is having issues or coming up. It's a star CLI, stop services, stop this service, disable this service, all of that stuff. That's a CLI available. So we can go through this more based on, this is very specific to the StarNet architecture. So without knowing that, you can't really use the commands there. DCLI is more user services sort of centric, so it's easier to use.
What is ZCLI? That thing is...
So ZCLI is the one that we use. So if I draw the picture, right? So there is host, there is ZVM, there is zhost, and then there is Sky.
Right.
And in the Sky there is a host, and there is a zCloud as a VM.
Right.
We run everything in a VM. We don't do much in the host. Even in the Sky, we only do some network configuration to connect stuff up, but there's no processes.
Why is that so on the cloud thing?
So it's easy to migrate stuff back and forth and start new instances. It's virtualized.
Isn't Ceph running under zhost?
zhost, yes. Yeah. So what we run, here we run a few more things. So here we run, with a Star Agent, CephCon, Ceph modules, OVS also runs here. There's a bunch of Nova Compute. On the host, there's a few stuff that runs. Our processes are minimal. There's also
things that have to provision resources have to run on the host.
Yeah.
Right?
So this is where the ZCLI is. So ZCLI is a CLI that we use on the host, and this is what we actually expose to the customers also to give them commands to change IP addresses or host names or validate accounts and so on. So over time, what we'll actually do is build a UI server on a host, so you can just connect to it using a browser on port 80 and do whatever you're doing in ZCLI as commands on it. And Star CLI is a CLI that's used in here to manage the cluster state and everything. And over here is in the zCloud here is DCLI sort of works as a distributed CLI, because you just give it an IP address, it talks to it. So it's not really specific to running inside one sort of a thing, but this is where the DCLI is. And the Sky CLI is something that is equivalent to Star CLI to sort of do the distributed cluster management.
By the way, does ZCLI expose a way for you to take this host off this cluster? Like
When we have the feature implemented, yes, we will.
Okay.
We don't have the feature, the vacate feature, we're working on it, right? Yeah.
I see. Okay.
Yeah. I mean, so most probably we'll start with star CLI exposing that thing, and from the ZCLI we can call the same RPC call to implement the same thing.
Sure.
Yeah.
No, but when you do validate account for a host,
Mhm.
it immediately connects and our Sky knows about this host.
Mhm.
I want to say at some point, okay, I'm done with this host. I am going to remove this host from
Mhm.
this cluster,
Mhm.
and maybe I will replace it, upgrade it.
Yeah.
Not software, hardware itself.
Yeah.
If that has to happen, you have to have a way to.
Yeah. No, I'm saying first we need to write the code in the system, distributed system, which takes it out, which is what BBK is working on. Once we write the code, there's just an RPC to call, which star CLI calls as an RPC,
Okay.
and we'll add the ZCLI call as an RPC and add it to the UI also, and then add it to the UI here.
Okay.
So once you have the basic functionality working from the cloud UI, you don't need to go to the host.
Right.
From the cloud UI, you click on a host and say remove this from the cluster.
Correct.
And the archivist send a command here and do the right thing.
Okay. Then they will have a brick
So right
setting
now
there.
you can actually delete the account you validated, right? So in one of the hosts you can delete the account, but the whole thing does not happen properly.
Yeah.
Yeah.
On each
No,
side,
you
right?
can
So we
delete
can-
it there, but the cloud will still keep thinking that there is some.
Exactly, so we need to plug in those things first.
Yeah. Okay.
Yeah.
I got it.
Okay.
Uh,
Any other questions?
Yeah, I have two questions, but it is not on the. This is high level
Okay.
design. Right? So I have a specific question on a specific component.
Mhm.
For example, the OpenStack management layer. So we have
OML?
OML.
Mhm.
So we have OpenStack, and how? What is the extra thing when we think of OpenStack OML basically? What is the extra thing that we added there? Is it the ensemble and etcd related things?
Yeah.
Or how is it?
Actually, I don't think I talk too much deeper about it, sort of a thing. But I can do a quick overview. The idea is that the way conceptually think about it is that there is a set of machines, okay, on which we are running an ensemble layer. This is basically a distributed cluster management. It's a cluster manager, okay. On this cluster manager, we are running multiple distributed applications. Okay, and one of them happens to be OML, the other happens to be ZML. And if it's in the cloud with the same ensemble, and we run CML, right? And what this is really saying is, this guy doesn't know about specific services and what's going on. He's more worried about, okay, which hosts are alive, who's talking to who's available, who's up and down. That's what the ensemble is trying to do, right? Maintain a leader, saying, okay, I'm polling everybody, checking everybody's when everybody's fine. What the OML is trying to do is more OpenStack specific, okay? And what its basic thing is, there are services, okay, multiple services, and there are ZVM services and zhost services,
Okay.
okay? And I need to do something about each service needs to run on 1 to n number of machines, either 1 or either n or k sort of a thing. And then the health and liveness are my responsibility. So what I'm going to do is I'm going to start these services, keep them running, keep monitoring the health. If any of them fails, OML is like responsible for bringing it back up, either on the same node or some other nodes. And it's also like over time, it's like it has to get more sophisticated. It's like I retried here, it's failing too many times here. Okay, let me go start somewhere else because of whatever be the issue. And it does that for both ZVM level services and zhost level services.
Okay.
That's what it does for OML. So if you look at basic thing, like Nova service. Nova service is an example. So as a simple thing, there's a Nova service.go file in StarNet, right? So what this basically describes is this describes commands to start, stop, status, configure, right?
Right.
So just based on this sort of a library description of how to start a service, OpenStack OML layer can basically decide, okay, I'll do status, check if everything is okay, then I don't need anything. Any other status comes back with like something that, so it doesn't know about what the status implementation is. It basically says there is a Nova service, the implementation of that is modularized into this one. So then it's, If it's not working, then I should maybe try to stop it here, start it again, or start it somewhere else and all that stuff.
Okay.
Now there is some level of dependency between Nova service and other services. The Keystone should come up first, Nova second. That part of the dependency is not like tabularized, not in a table, but it's explicit in the code.
Okay.
Over time, think of it really as a service management layer. And if you abstract it more, you can even put a dependency graph there and say, oh, this A needs to come up before B, as opposed to knowing Keystone before Nova.
Now that OML should take care, right?
Yeah.
He should
Yeah, that's what I'm
which
saying.
service to bring up first.
Yeah, it does it. I'm saying it's not generic enough to say, give me a list of names and dependency order and I'll automatically take care of everything. It basically explicitly knows about OpenStack, Nova, Keystone, right?
The other thing is that, say for example, a user creates a VM, so that request should go to the Nova service
Yeah.
in the cluster.
Yeah.
So that routing also happens only after it comes to OML leader, or how is it?
No. So OML leader is responsible only for providing where it is. But the actual, it's like a control plane.
Direct. Okay.
So the data plane of how the request actually get to the